So in the Unit 1 packet, page 3, we start off talking about outliers. So the notation can be a little iffy, a little wonky. Any value that falls outside the range of, well, that is considered an outlier. All right, so let's dive into this a little bit more. So LQ, also known as Q1, no help there, right? Stands for the lower quartile. Also known as the 25th percentile. All right. Minus 1.5, the IQR. IQR is going to be the difference between the lower and upper quartiles. I'll get to that in a second because I haven't defined what the upper quartile is. But that being said, you probably can figure it out based on what I called the lower quartile. Right, so the upper quartile is UQ. And that's the 75th percentile. All right. So it's, and let me actually clean that up because I want to put the alternate notation in there. So Q1 minus 1.5 IQR, which we still need to define, comma Q, we'll call that Q3. What happened to the Q2? I'll get to that in a second. Plus 1.5 IQR. All right. So we just need to know that IQR, poor quality Q, IQR is equal to Q3 minus Q1. My Q game is off today. All right. Stands for the interquartile range. All right, the interquartile range. All right, Q3 minus Q1 or UQ minus LQ. Either way. All right, so a lot of information there, but what we need to do is identify these values. Now, there's a couple of ways to handle it, and I promised on the previous page that I'd show you some calculator stuff. All right, the first thing you need to do is identify the median. The median is also known as Q2. So that's what happened to the Q2. That would be the 50th percentile. If every Q represents a quartile of data, then Q1 is 25th, Q2 would be 50th, and Q3 would be 75th. All right. So then divide the data in half. Find the median of the lower half. That would be your Q1. And then find the median of the upper half. And that would be Q3. And the rest we can do just by plugging into that lovely looking formula. All right, so then plug into formula. Okay, so let's do it. So I got 2, 4, 5, 6, 7, and so on. What I'm going to do here is I'm just going to do what I did on the previous page. I'm going to count inward. So I got these two values. Let's count inward. Whoop. Whoop. A couple of whoops. More whoops. Lots of whoops. All right, so that gets us to the center value, which is right here at 7. All right, which is going to tell me to take the lower half of data, so any value that's below that 7, and then take the upper half of data, which would be any value that's above that 7. that big. All right. And then just kind of treat them as if they're their own problems. You know, brand new problem over here. All right. So this problem, let's get actually pretty, I like to have a nice heavy duty highlighter. All right. So move it inward. And then you see it's the same idea as on the previous page where it's the space in between the 4 and the 5. All right. And so that's where my LQ would be, or my Q1, as we're calling it now. All right. So again, and you know, let me make this a little nicer to look at. I don't think it's ever going to look nice, but you know, a little nicer. This is going to be my lower half of data. Oh, interesting way of spelling half, right? Half of data. And this would be the upper half of data. All right, we'd follow the same process. Work our way to the middle. Whoop, 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 whoop. And that gives us, oh, line draw tool, if you please. There we are. That would be our Q3. All right. Now, the other question would be, okay, well, cool. What is the Q3? What is the Q1? Well, what's halfway between 4 and 5? 4.5. Or 4.5. What's halfway between 9 and 10? 9.5. If you want, you can actually go through the process of adding 4 and 5 together, just like we did on the previous page, simplifying, and that was funny looking, and then dividing by the value of 2 because there's two values, two data points. But I think just thinking about what's directly in between those two numbers is probably a little bit more user friendly. All right. So then, in order to, so we found the Q1, the Q3. Now I got to plug it into the formula. So we're close. I just need the IQR. All right. So IQR. I didn't create a whole step for that because I just figured, well, it's just Q3 minus Q1, which is 9.5 minus 4.5. So that gives you a result of 5. So now if we're plugging into that formula, let me resize a little bit here. Make sure every setting is appropriate. I'm going to take my Q1, which is 4.5. I'm going to subtract from that 1.5 times my IQR, which is 5, comma, my UQ, which is 9.5, plus 1.5 times my IQR, which is 5. Simplify this expression. It's going to give you an interval. All right, so 4.5, I should say, minus 1.5 times 5. On the low end, we're looking at -3. On the upper bound, 9.5 plus 1.5 times 5 gives you 17. All right, so the interpretation is going to be huge here. So what this gives us is an interval of values that are not outliers. So any value between, if I can write, -3 and 17 inclusive, meaning it can be a -3 and it can be a 17, is going to be considered not an outlier. All right, so any value in between those two numbers is not going to be considered an outlier. So then we start thinking, okay, well, what is an outlier then? So our conclusion would be Therefore, I like to use the 3 dots in the form of a triangle to represent therefore. You don't have to do that. You can just make a statement of the final answer. But I think it's kind of cool to write that. 42 is an outlier. All right. All right. And so when you think about what an outlier is, based off its, the word itself, outlier, a value that lies outside of what you would expect to see in a data set. All right, 2, 4, 5, 6, 7, 8, 9, 10, and then 42. All right, so 42 probably shouldn't be there. All right, and so this is a mathematical approach to help us determine whether or not a number is an outlier. All right, we'll come back and revisit this concept repeatedly throughout the course, and so this is our first kind of dipping the toe into the water. All right, so we're going to shift gears and talk about frequency tables, and with those frequency tables, we have a new process for finding the mean. It's actually pretty simple, but the notation makes it seem a lot more complicated. What this is telling us to do is add up the column containing x multiplied by f. I think the one on the bottom probably makes sense once you realize and get used to the fact that that funky looking E means add up. All right, although my up looks not very up-like, it looks op. So I need to create a column of x times f. So it's telling me to multiply, that's not a pen, multiply the columns. 1 times 10 is equal to 10. 2 times 3 is equal to 6. 3 times 1 is equal to 3. 32. And then 25. So what this formula is telling us to do is add these 2 columns, because this is my F column. 10 plus 3 is 13. All right, so 10 plus 3, 13, 14, 22, 27. 10 plus 6, 16, 19, 51, 76. So the x bar is just going to be the sum of the x times f column divided by the sum of the f column. And so I would assume we're going to get an approximation there, so let's take a look. 76 divided by 27, about 2.8-ish. And that is page